Hello. In this section, we're going to be conducting a hypothesis test, but we're not going to be doing it for a population mean. We're going to be doing it for a population proportion, or a percent. These are used when politicians want to know like what percent of their constituents support a bill, or if there's some quality assurance engineers test, if they're going to check like the percent of parts that may be defective and whether that is meeting industry standards. Recall, if we're going to be using a normal distribution to approximate a binomial, because we're dealing with a binomial situation here where people are going to be saying yes or no, or parts are good or bad, then we had the following properties for a normal approximation with a binomial. The first one is that the mean is n times p, and the standard deviation is going to be the square root of p times q divided by n. That came from the standard deviation for a binomial being n times p times q, the square root of it, all divided by the square root of n. It simplifies to this. So we're going to be using a normal approximation for a binomial proportion. So we're going to be doing a z-test because we're dealing with a normal approximation. In order to do this, we need a large enough sample. Typically, we say at least 30 if it's going to be for a population mean, but we're dealing with a population proportion. So we check this by making sure that n times p and n times q are both at least 5. If both of those are at least 5, we have a large enough sample, and a normal distribution will do a good enough job of approximating it. Our test statistic is going to be the sample proportion that we get from our sample, and the z-score is going to be determined using the following. It's our sample minus the stated value from the null divided by the square root of p times q divided by n. Otherwise, really all the steps that we've had before are the same. Verify we can use a normal distribution, state our hypotheses, calculate our z-score, determine the probability, and make our decision and state our findings and contexts. Same steps we've been doing. Example number 1. A medical researcher claims that 5% of children under 18 years old have asthma. In a random sample of 250 children, 9.6% say that they have asthma. At an alpha or significance level of 0.05, is there enough evidence to reject the researcher's claim? First off, verify we can use a normal distribution. Note you need to use p and not p hat because we assume the null is true until proven otherwise. So I should probably have gone back and stated that we need it. Oh, it's right there. N times p is greater than 5 and n times q. Those are not p hats and not q hats. So we need to use n times p. So that'd be 250 times 0.05, which is going to be 12.5. And check this. If this one is at least 5, this one certainly is because that's 0.95 times it. But just to do it, we'll do it anyway. It's 237.5. So both are greater than or equal to 5. So we have a large enough sample. Step 2, state our hypotheses. The first one was that the null is that the percent is equal to 5%, 0.05. The alternative is that it's not, so it's not equal to 0.05. Step 3, calculate the z-score. Again, note that we're going to be using p and not p hat for the bottom portion because the null is assumed to be true until proven otherwise. And that was stated right here. You'll notice it's p's and not p hats and q's and not q hats. This is going to be then p hat, the proportion was 9.6. Well, we should honestly do 0.096 minus p 5%, so 0.05 divided by the square root of p is 0.05 times 0.95 divided by our sample, which was of size 250. So we get 0.096 minus 0.05, that would be 0.046 divided by the bottoms. 0.05 times 0.95 divided by 250, and then take the square root of that number, and we get 0.0138. So dividing those two, we get a z-score of 3.33. Find the corresponding probability. We're going to be doing that. Maybe we should first draw the distribution. This is going to be a two-tailed test because it's a not equal to. So we've got negative 3.33 and positive 3.33. We want the probability of being in either one of these because it just said not equal to it. So let's find one of them. That'd be normal. CDF, I'm going to find the left tail and double it, so negative 1,000 up to negative 3.33. Mean is 0, standard deviation of 1. When we do that, I end up getting corresponding very small. It's 0.0004. If I double that, I'm going to get my p-value 0.0008. Make our decision. Well, that's a very small p-value. So with a significance level of 0.05, there is definitely enough evidence to reject the null hypothesis in favor of the claim that the percent is not equal to 5%. It actually appears it's higher than that. Or if we were interpreting, which is the way that statistics is moving toward, instead of comparing to a significance level, we would say there is strong evidence against the claim that 5% of children have asthma. Actually, technically, if it is 0.008, we would say there is very strong evidence. But either way, we got a strong statement. Note, we could also use the calculator to do this. When you're doing this in the calculator, you go to Stat, tab over to Test as a 1 proportion z-test. You need to give it the stated proportion, which is 0.05 in this case. 5% were claimed to have asthma. This is important. X is the number who said yes in the sample. Sometimes you might have to calculate that. We said it was 9.6%, and there was 250 people sampled, so it'd be 0.096 times 250. That would be equal to 24. That is the number that have to go in for X. N was equal to 250. We were doing a not equal to, so the two-tailed test. And there's the p-value, again, 0.0008, so very strong evidence, actually. We're going to try one more using technology from the get-go instead of going through all steps, but I would recommend doing one with all 5 steps before using the technology going forward. So here's the second example. A politician claimed in a speech that at least 60% of adults believe that cloning animals for any reason is morally wrong. To test this, a news program randomly surveyed 300 adults and found that 162 believe that cloning is morally wrong. At an alpha level of 0.05, is there enough evidence to reject the politician's claim? So first we need to make sure that n times p and n times q are both bigger than 5, so 300 were sampled. We have to use the claimed p's and q's, so 300 times 0.6. So 300 times 0.6 can be 180, which means there has to be 120 going the other way. And yes, both are far larger than 5. So we have a large enough sample. State the null and alternative hypothesis. The null in this case would be that the speech said at least 60%. So p is greater than or equal to 0.6. The alternative is that p is less than 0.6. Now, steps 3 and 4 can be done using the calculator. Use a 1 proportion z-test. The claim was 0.6. That's the null hypothesis. 162 said yes. We are trying to find the likelihood of it being less than as the alternative, so we're going to choose a left-tailed test. And our results are shown. We get a p-value 0.017. So we would say that if we were using a confidence or a significance level to compare to a 0.05, there is enough evidence to reject the null hypothesis in favor of the claim that the percent is actually less than 60%. If we were using our levels, the inference statements, we would say, at what is that, 0.02, we would be in the moderate evidence level. So we'd say there is moderate evidence, almost moving though to strong evidence against the claim that at least 60% of adults are against cloning and in favor of being less than 60%, because we just observed something occurs 2% of the time. So that's fairly rare, 1 in 50. Going to give you a chance to try, and then that'll really be it for this section. It's essentially the same process we went through, have been doing. It's just for a proportion. So yours is that a research center claims that 25% of college graduates think a college degree is not worth the cost. You decide to test this claim and sample 200 college graduates, asking whether they think a college degree is not worth the cost. Of those surveyed, 21% reply yes at a 0.1 significance level. Is there enough evidence to reject the claim? You can try it using technology. Pause the video, come back after you've had a chance to try. You go through the whole process. You would find that the z-score is negative 1.31. And that returns a p-value of 0.19. So there is not enough evidence to reject the claim that 25% of college graduates think a college degree is not worth it. So the null stands for now. And that is it. Thank you very much.